Okay, on to the last problem here. So question 10 is a question on circuits for filtering. And it says the FCC allocates 10 kilohertz of bandwidth for each AM radio station with station numbers corresponding to the frequency in kilohertz. You want to design an RLC bandpass filter that would allow you to listen to 1430 AM. So first is draw the circuit diagram for the RLC bandpass filter, clearly indicating where the input VIN is connected and where the filter output Vout is measured. So I'm just going to go with the same solution that the solution online has, just to be consistent here. I know we looked at a different configuration of the RLC filter in class, but I think it's probably best just to go with the solution that's here. So we start with our V in. This is our AC wave. Really, it's our sine wave coming in, but it's the same as having AC current coming into the circuit. So we're going to have that. We're going to connect to a capacitor. So we have our capacitor C here, and that is in series with an inductor. So we'll have that connected up there. And then that is going to go to our one output. So this is our positive terminal for V out. On the bottom here, we have our negative terminal for V out. And then in the middle, to just reduce the total current of the circuit, we're going to have our resistor R. And there's our L there. So that's what the circuit looks like. Again, we have a different variant of this, which is RLC, sort of in series like that, with the capacitor in between the two lines. I think they work roughly the same, but I am not an electrical engineer by trade, so I can't tell you if there's some subtle difference. But I would say this is the one from the solution that's probably good enough and cross-referenced in my old electronics textbook. So part B here, assuming the R for the circuit is fixed at 100 ohms, determine the required value for your inductor and capacitor. So we need to figure out what we're given here at this point, which is we know our resonant frequency. If we want to listen to the radio station, we want to be centered around 1430 kilohertz. And that's just coming from 1430 AM here, and the fact that the stations are in kilohertz, the AM frequencies. So we have our resonant frequency. We know that we're allocated 10 kilohertz of bandwidth. So our bandwidth for the filter circuit is going to be 10 kilohertz. And then we're given our value of R, which is 100 ohms. And so that's what we have to start with. Now we need to dig into our equation sheet. And this is all stuff that you would want to have written down so that you're good to go. And we'll find first that Q is equal to FR over the bandwidth. This is the quality factor of the filter circuit, is what we're going for here. And we have those values here. We can calculate 1430 kilohertz over 10 kilohertz, and that's going to give us 143 for Q. And we also have that Q is equal to 2 pi FRL over R. And you might be able to guess at this point, now that we have Q, we have R, and we're looking for L, we have FR. We can rewrite this equation. We can say L is equal to QR over 2 pi FR, just rearranging terms here, multiply by R, and then divide by 2 pi FR. That gives us L. We've plugged in our values here. We have 143 for Q. We have 100 for our resistance, and then over 2 pi 1430 times 10 to the third to get out of kilohertz to hertz. And that gives us an answer of 1.59 microhenries. So that is our inductor. That's our the required impedance for that. And that's what we're looking for there. And then finally, we want to continue on with the other equations that we know. We know FR is going to be equal to 1 over 2 pi square root of LC. Again, just coming from the notes, we've previously derived this, so we know that this is the equation for the resonant frequency, and allows us to sort of choose a capacitance and then figure out the inductance, or choose the inductance, figure out the capacitance, and or figure out the resonant frequency from those two values. So that's what we're given. We switch terms around a little bit here, and we end up with C is equal to 1 over L times 1 over 2 pi FR squared. And this is just, again, multiply through by LC, or square root of LC, divide by FR. and that gives us the 1 over 2 pi fr term, and then we square everything to get rid of the square root. That squares that term. These two just get unsquare rooted, and then we divide by L, and that gets everything on the right side of the equation for us. So we plug these values in, and that leaves us with, if we push through all the numbers, 7.79 picofarads. And that's it. That's all we have to calculate there. We know C, and we know L at this point, and that's what we were trying to calculate. So we are done. That's going to allow us to listen to 1430 on bandpass. And that's it for that exam. Good luck.